Hey everyone. So today I want to share very cool thing about what we have with Flare confidential compute, that is x402 payments. Let's wait for like a minute or two while everyone joins, and then we can start. And while we wait for everyone to join, please ask questions, any questions you have about the topic, and I will try to answer them at the end of the webinar. Thank you for those who are joining. So let's wait for, let's say like roughly less than 2 minutes while everyone joins, and then we will start this webinar about paid AI APIs, x402 payments, and Flare confidential compute. Please ask any questions you have in chat, and I will answer them at the end of the webinar. All right, I think we can tune a bit down music, and we can start. I hope you hear me loud and clear. And yeah, let's start the topic about how to build paid AI APIs with x402 and Flare confidential compute. So yeah. So today's plan in this webinar, it's actually based on the previous webinars that I explained about Flare confidential compute, and also there have been other recordings from DATCON conference as well. You can go and check it out, that recording on our YouTube channel or socials. But I will try to sketch some ideas what is Flare confidential compute. So we'll check plan like three main things. What is X402? So basically, what is this payment standard? What does it stand for actually? And how AI agents can use it? Because when this standard was implemented, pretty much it was never used in nowadays, like how we use internet. Then secondly, we will talk about Flare confidential compute and X402 payments, like how to combine those, how those payments can be used, and then confidential compute can use these payments on computation on Flare network. And then a short demo. I will show paid API using X402 and also from AI perspective, and how Flare confidential compute is part of all of this. I will not focus that much explaining Flare confidential compute. So like I said, there we have other materials beforehand. But in essence, Flare confidential compute, it's just the execution environment enclave where you can run code, various interactions, and that is off-chain, but the whole interaction, how you interact with the TD machine and how you relay back information on-chain, that is obviously signed with Flare systems protocol, and that can be observed, but you can hide confidential or private execution in these secure enclave machines. And what if we think from AI agent perspective, then nowadays AI agents, they are right now we pretty much consume information. We don't have so much possibility to write. Okay, there are some ways, but more or less that is centralized. You need to trust some authority, and that is not scalable at all. And also there are limitations. There are limitations in like payment gateways. Like if we use, for instance, regular payment gateways, we are fixated with fiat, or and that is not scalable. It's very slow. There are no way to use these like micropayments, especially on the fly. And yeah, so imagine if AI agents could discover and locate, they can locate that API. There's API that needs to be paid for, and do it dynamically. So basically, they figure out either using skill or you feed specific product, and AI agent discovers, oh, okay, I can consume this information, or I can get a specific set of information which is maybe valuable. Maybe you need need this up-to-date information to make your own. AI agent needs to do their decisions. So first one is discovery. Then second is payment. So basically, okay, we know that we need this set of information, or we need to consume, or we need to write something, write data, whatever it is. Then there are payments, and so then we pay. We can pay with like micropayments, or it can be like even bigger payments. It actually doesn't matter, but here it shines that it can be micropayments. So we can pay very small fractions of assets on the fly, and after we make the payment, then we can use, either we consume or we use specific service. There is no kind of registration, nothing, like there are no accounts, no API keys needed, no subscriptions, no invoices because everything is on chain because these payments happen. And not ideally, but like these payments happen with, for instance, USDT, like stablecoin. So pretty much any ERC20 token can be used as payment for with x402. And that how what x402 actually opens doors for us. So regular flow right now, it doesn't matter if we use blockchain or not. Like we need some kind of setup, then create account, get API key, then add credit card or I know wallet access, whatever. Then manage subscription. Subscription renews every month, every year, whatever. And then we call API. Okay, it works, but there are a lot of limitations, especially like we need like some kind of card, you need to sign up. There's like account involved, either with a wallet or whatever. There's still some kind of account needed. And with x402, agents can run autonomously. Agent initiates firstly, then the request is sent. Hey, I want, for instance, in this example, we will get weather information. So agent finds, okay, I need up-to-date weather information to make some kind of predictions, for instance. Or in this case, we will look at weather insurance. So we need up-to-date weather from a trusted API, and that costs us money from the provider of this data set. Then the request is sent. Then it comes back x402. So actually, it is HTTP x402 error, which says, hey, you need to pay such amount to this receiver. Then you will get access to this information, or you can write or you can consume whatever it is. Then the payment is made with stablecoin, so let's say with USDT, and you get a result instantly when retrying this action. And how it works step by step. So let's check this diagram. So we'll check the weather case. So there is client, which you can be AI agent, MCP. It can be even actually front end. It doesn't matter that much for x402. So we want to get weather. We go to the API endpoint. So there is kind of backend component who orchestrates this HTTP requests because it happens on Internet Protocol. Then it sends back the HTTP 402 payment required error. So, hey, okay, you can get this information, you can do this thing, but you need to pay such amount of money, assets. Then there is payment on Flare, and we will check in this example USDT 0, so which is USDT stablecoin plus request, what we want to do. And then the API sends back result because the payment was made. And to be honest, that's so simply when we can check here this old flow. We need account. We need some kind of API key. Credit card. We need to manage subscriptions because that service will charge us again in future, which we already forgot actually when we add credit card. And with this approach, it's all gone. We pay for what we want, not that we pay continuously for, and we forgot that we have some subscriptions even. And okay, we pay for API, but what is this kind of API? That is also second second thought of this webinar, and here comes Flare confidential compute into place. So for instance, paid API, there are different things needed. For instance, like, I know, Anthropic OpenAI API keys. It wants to interact with a private database. It has some kind of algorithm. It holds or processes user secrets or interacts with other blockchains. So, for instance, from Flare, you can interact with XRP, Bitcoin, whatever you need to hold these keys, how you interact with these wallets. And all of that kind of is encapsulated in API, and with Flare confidential compute, you can do it in with confidential approach, so no one can alter this information, even the person who deployed this TE in secure enclave, because nothing can be altered or written, because that is secured by the chip itself or the hardware. So here comes Flare confidential compute into the place, and I will shortly explain about how it works. So basically, we can check from 3 steps in this webinar. Of course, there is a lot more into Flare confidential compute. I advise after this webinar to check the previous recordings or previous materials on Flare DevHub. So the first one is requesting. So the user triggers some kind of computation, sends and sends encrypted information. So or sensitive inputs to the place where it will be processed. So nothing sensitive or private will be written on chain. And then there is the enclave, which is isolated in hardware, so no one can alter this information, and no one can write or read in this secure enclave that is secured by hardware chip. And then once the work is done, then the attestation, the proof of this work, of this instruction, is sent back to blockchain, and that is recorded and is verified by Flare network for Flare systems protocol. So this how we can hide away this like private execution from blockchain, but still we relay back the outputs. So we don't know. So we can run some private algorithms, for instance, in this enclave, or we can hide away in this previous slide, like interaction with database, how we do that. What's our trading algorithm? So that's our secret, actually. Some secrets, interaction with other blockchains, or API keys. All that can be stored in this T enclave. And how it all ties together. So let's check here in this slide. So x402 with Flare confidential compute. So we'll go over these 5 steps. So first one is AI agent. So basically, AI agent initiates HTTP request to access paid API. It can be consuming, it can be write, whatever it is, it doesn't matter in that sense. So x402 API, you hit some kind of gateway. That gateway checks all the boxes. Okay, you need to pay for this API call, and it returns HTTP x402 error. And so it tells that such kind of payment is required, and you need to proceed with this payment, so to continue. And Then there is crypto payment. So agent pays with crypto, usually with stablecoin. It is already verified, so we can verify that happens, and then initiates the Flare trusted execution environment machine, which is in Flare conversational compute, private computation, and it runs securely. It hides away all the information. It's totally isolated by hardware chip, so no one can alter this information here. And the fifth, the last one, is result. So it's cryptographically signed, and you can verify this signature on blockchain. So basically, it's signed by this specific machine, because each machine has public key, and it signs with this public key. So you can verify, okay, it came from the right machine. So this is how you can trust this machine. You totally should do that when you relay back results on chain. So we have talked about that previously, so I will not talk that much about this specific case. And let's check out the demo. It's on our GitHub, sorry. And I will post the link after this webinar. So don't worry, you can take screenshot of this, or I will post that on socials as well. So don't worry. So let me bring let me find right okay, and let me make this a bit bigger. So this is the application we will check out today. So let me hide this one. It's based on the previous webinars material. It's based on weather insurance application, but in this case, I have added AI assistance, and also x402 payments. So let's check out from the UI how it works, and then we will jump in code. And again, I want to tell that if you have any questions, I will try to answer these questions at the end of the webinar. So please stick around and ask any questions you have. So let's check out from the UI how we can use x402. Let's start with very simple, without using AI, fetching weather, and we will check out mostly this in this webinar. So we want to ask, what's the weather in Berlin, Germany? So let's fetch that weather, and what it does. Let me refresh this one and do like this, so you can see the MetaMask. So you can see the MetaMask as well, otherwise you won't see it. So what it does, it asks us to approve 0.000001, so sixth digit after decimal, in USDT 0. So we can see that it shows that that's the fee. In this example, that is hard-coded, but ideally we can make it dynamic. For instance, we see that there are more consumers, so obviously we see that this data is more valuable. We can make this fee variable, dynamic, sorry. So we don't need to, we can do whatever we want pretty much. So the user is asked to approve, This case, everything happens here in UI, but we'll check from AI side as well. So we confirm. And then we see that here we approved spending this USDT 0, and the trusted execution environment does its job, and it gets back the weather information. And what it did actually was it's using Open Weather Map API in trusted execution environment. So we will not go so much deeply into how the Open Weather Map is being used because we have the previous recording. So I would encourage to look at that recording after this webinar. But what is interesting or important is that we see that we transferred such amount of USDT stablecoin to this address, which is configured as fee receiver for x402. And yeah, so that's how it works behind the scenes. We can even maybe check here. So let's do like this. So let's ask again. So we can see that actually when we were trying to fetch information, weather fetch, it gave us x402, error code was 402. And we can see that this is the information what we need to make the payment. You know, what's the asset, what's the resource we will be getting, what's the spender, and so forth. So, and what's the x402 version as well. So this is a 402 x402 payment specification. So I will not explain that much, but this is actually happens behind the scenes. So it's actually HTTP x402 payment required error, and that has been pretty much forever in internet world. And again, once we approve, it fires secure enclave instruction, and it shows that it was there was payment was done. You know how much we paid, and then there is a report as well. So and of course a request transaction, which is this one, and we can see that we made this payment. So that actually how x402 works in like bare essence. But let's look how we can integrate on AI side. Again, let's check from the UI, and then I will jump on the more on the code and technical explanation. So for instance, we want to, so we have the AI assistant. It's using OpenAI behind the scenes, but it can be Anthropic or local model. It doesn't matter that much. It's more that AI model figures out that it needs to make payment to fetch weather for Berlin, Germany. So let's check using AI system. And again, it fires up to user, hey, do you want to spend this amount to get this information? We could, I mean, possibly we should give some kind of access or wallet or their AI agent wallets coming out as well. I mean, popping up nowadays, that we can set some kind of limits and do some other sophisticated some stuff with these wallets and provide these wallets to the AI agents, but that's not the theme of this webinar. So, so the AI agent asks us, do we really want to pay this money? Because it needs this information to make something, for instance, to get the weather. We confirm. So the AI agent knows, okay, it can, retry, it gets the information, so it retries the result, and it fetched the weather. So again, we can see that there was a payment was made, and we get the information back. So we can see the weather report. And that is using Open Weather Map API, but the API key here is the very important aspect, is saved in trusted execution environment enclave. So no one can see this API key. So that belongs to this secure enclave. And this is how we can hide away information. And if we have time at the end of the webinar, we will check maybe other examples, but I wanted to show this bare minimum of functionality. Again, all this code is on our GitHub. You can check it out, how it works, how to implement that yourself. So don't worry about that. And I will share now code. So let me find that screen. Let's use this. So here we have the flow, and let's check in details a bit again. And this will be included as well in materials. I will push this canvas drawing after this webinar. So here we can look again about the fetch sequence, how it works more in depth. So here's the diagram. So client, which is AI agent or user interface, that doesn't matter that much, to be honest. It wants to fetch information about this specific city. So let's say it was Berlin in our case. There is a gateway, which is server component. So it checks, okay, you want to get this information, but you need to pay this money. You don't have funds already. It gives back, it gives back x402 payment. And then we approve to spend this stablecoin to the specific contract who will execute this Flare confidential compute instruction. Again, what are instructions in Flare confidential compute? We talked about that previously, but that is approach how we communicate with these T machines, and we load. We want to basically we tell that we want to do something. So these are instructions to this Flare confidential compute enclave machines. Then we post fetch retry. If you remember the network requests, we retried again, and then we go and to the blockchain part, and we want to get weather for this specific city, and we provide the payer, who is the payer as well, for extra validations on the side. Then on the contract side, it collects the fee. It collects this US stablecoin, and then it sends instruction to the Flare confidential compute. Hey, fetch weather for Berlin, Germany, and we provided that this was the payer. Then the T actually verifies that fee was actually collected from that specific payer. If it wasn't, if something was wrong, then obviously it won't give us information. But the thing is that the payment happens before we issue instructions. So pretty much that always should belong to the smart contract itself. Then the T goes to the API. In this case, gets the information, the weather report, and it relays back the information to the client. Basically, it signs a result with the public key. Remember, the machine, they all have public keys, and you need to verify that this result came from that specific machine that you requested information from. And then the result is, checked if it came from that specific machine, and it's presented to the client. Either it's AI agent, UI, whatever, it doesn't matter. And a bit about X402 payment handshake. Remember, we checked this very simple diagram, but here we have a bit more in depth. So first one is post request to the gateway that we want to, fetch weather information. Then it checks that if there is payment required, obviously, and it checks that if we have enough allowance. If we don't have, then we need to approve those assets to consume from our wallet, pretty much. Then we retry the post again here, and then it's checked again. We have enough allowance. Yes, we have. We can pay for this consuming this API, and then it's specified the asset spender amount. Basically, that is USDT who is spending and how much we are paying. And then on chain, once we have this payment done, we can initiate the getting weather information in this case and collecting the fee. And once fee is collected, in this case we are emitting fee collected. I don't have that screen, but yeah, we will check that a bit later. And we have a bit more in this diagram. Canvas, all the steps with all the code. It's very nice to check out what happens in this specific code that we will provide after this webinar, or pretty much that's already out there. And we can see here, I think it's very important what happens to the money. That when we do the HTTP post first or retry, then nothing happens. We approve. Once we approve, remember in the diagram when we approved, and only here on blockchain, the fee is collected. And yeah, later we pay only for gas. And let me quickly switch back. Okay, this one. If we check this this transaction, let's check out logs. So we can see that we are emitting actually fee collected event. So who was the payer? What was the amount? So that is actually in smallest fraction of the token. So we need to see the token decimals, obviously. And what was the kind? That's not so important in this case. And of course, transfer happens as well. We can see from whom to whom payment was done, because we were approving at first place. And let's get back to code. And obviously, I won't show all the code because there is a lot. Remember, if we go back to this diagram, there is client, which can be just UI, or in this case, also AI agent consuming via MCP with Claude, with Codex, Cursor, whatever it is, or even OpenClaw. Then there is a gateway, which is backend component, which pretty much here is very lightweight. It only job is to check if there is payment required. It collects, it instructs that you need to pay this and sends back the x402 payment instructions, HTTP 402 error code to where we need to send. Remember this network graph that we checked from browser. Then there is smart contract, which in this case is on Coston 2. That is not yet Flare confidential compute. Then there is Flare confidential compute, where that is T extension, which runs in secure enclave, and it does this private execution. And there's Open Weather Map API, where we are fetching actually this information from. And let's check briefly some of the code parts. So starting with the gateway. So here is, obviously I will not go all the code, but here's the function what checks if we need, payment, and it reads the contract for what kind of payment for a fee token. What's the fee token there, and then we check that if we have allowance set in place, if the user hasn't given allowance, or in this case AI agent hasn't allowed beforehand, then obviously allowance is not there, and it needs to return 402 error. So it's building the payment requirements here. So what's the fee token? What's the amount needed, and what will be the contract that will receive or execute this transaction. Then we have in this file gateway wallet TypeScript. Let me make this a bit bigger. We have after we have the we got the payment, then we are executing contract call. So in this case, we are using WAGMI. So it's a tool how to interact with blockchain smart contracts. So once we got the payment, we are writing the contract and we pass these parameters here, like what's the function, what's the value, and so forth. In this case, we were calling get weather, fetch weather, get weather function. So this is the smart contract side. Let me do a bit like this. So and the smart contract, what it asks us, it wants city, it wants payer, and pretty much that's it. And quickly, I'll jump over Flare confidential compute part. So there is TE machine registry. So you get a random TE machine for your specific extension. In this case, it gets only one TE ID. We are not using cosigners. We could. And here is the important part that we are creating instruction. So instruction has operation type, operation command. So in this case, that is getting weather, fetching weather, and we are encoding the message as well, which is the city and also payer. So that will be untangled later. So we will verify that this payer actually made the payment. And we send off to the extension registry, and or the machine, proxy, picks it up and instructs the extension to do its work. How that specifically works, check out previous recordings. So I just briefly explained here Flare confidential compute part. And if we go a bit further, so this is the extension part. So that is written in Go, but it can be written pretty much in any language, this Flare confidential compute extension. So, and this function here in the extension verifies if the fee was collected in this specific, transaction. So it checks if the fee was it checks all the logs, and it checks if the fee was collected from that specific payer. Of course, if fee was not collected, we return error and we don't continue our work. So that is very important. We don't hit the API because actually we need to pay for API usage, or in this case for hitting the Open Weather Map API. Okay, let me make this bigger, sorry. Yeah, this code will be available after this webinar, so don't worry. And yeah, if we go further, this is the user interface part. We execute the gateway. The backend component. We want to fetch the weather, and yeah. So there is no sophisticated stuff. So we execute. If it's fine, it gets us 200, which is okay, or HTTP 402 error back, and then we need to make the payment. And the last part here, before we head to the questions, is AI agent side when we are fetching weather via x402. And again, it just describes that we need to hit this endpoint, and we need to specify city, what's the payer, and pretty much that's it. The AI agent itself figures out that we need to make the payment. Okay, we need to tame the prompt. We need to write that, okay, x402 payments are being used. And before we head to questions, I want to share very shortly this information here. So this is the information about x402. You can read the information more where it is, or x402. There's, I think, other information. Yeah, we can check, like for instance, Coinbase blog, or there are other informations how we can. Yeah, I think it was. Yeah, it was this one, and yeah, here is more information about x402, how it works behind the scenes. So that's it about the webinar. So let's go over questions. So let me read the chat, and you can ask questions if you have, and I will try to answer in the last 10 minutes that we have here. So let's check out question from Crypto Crazy 589. So the T attests the compute what attests that the agent can't overspend. Yeah, so that is a bit out of this webinar, but either you can create this in Flare Confidential Compute as well. So that was not the part of the webinar. Part was more how the payments work with Flare Confidential Compute. You can set those limits, but like I said, they are AI agent wallets. I know that MetaMask is working on something like that. You can build your own rails. So definitely, I think that will be big theme for upcoming year or two, how AI agents can make payments. And I think we are in very good position because blockchain will be the place where those payments will happen, because regular banking payment rails can't handle that, like, for sure. So then there is a question from Vasily: when should we expect AI agents having wallets already? And the MetaMask is working on something. I know that other companies are working. We are quite in early days. People are, what they are doing, they are setting up accounts, saving private keys somewhere where they have limited funds, but obviously that is not scalable for wider usage. Then Vasily asks again about in x402 payments that happens before the agent sees the full response. What would protect again agents from having wrong response? Of course, like backend as well. That's can be attack vector, and some kind of integrity should be there. I think for sure. That checks all the if all the dots fit together, if it's the right backend. And again, the last verification should be on blockchain if the payment was actually made there. So even if you intercept backend, on the blockchain, you need to check the payment, and that happens on blockchain. And yeah, I think I answered that question as well. So there is another question regarding the handshake. If client retries the original request after dropped connection, payment already sent, response not yet received, what happens? In this case, in Flare Confidential Compute approach, once the instruction is instructed, T is instructed to do the work, it pushes back the result. You can consume this result many times as you want. So actually, if you drop connection, the T still is doing its work, and it has the result there. So you can, once you are back connected to internet, the application should be built up that it checks the previous requests. So all the logs are on blockchain. If payment is made on blockchain, it's sent to T. So it doesn't matter. So the truth is always on blockchain in this case. So if you have any other questions, you can ask while I show the let me do like this. And I will show, meanwhile, this last slide that we have, which is thank you. And if you have any questions, ask now, or you can ask later in X, or you can send to me or to Flare Dev's account as well. And here you can scan this QR code, and there's a small quiz. And when you finish the quiz, you can actually get some nice merch. So there will be, lottery, and the merch will be sent to you. So you can get some very cool Flare merch shipped to you. So yeah, and I want to finish with thought that I think we are still in early days with X402 payments, but I think it opens wide doors that data providers or services, they can ask for micropayments. They can do it dynamically. It's much faster on blockchain. You can see if that actually happened. And in combination with Flare confidential compute, you can offload on blockchain applications private execution, confidential execution. You can save, API keys, access to other blockchains, and I think, and putting AI agents into this case, they can find, okay, we need to interact with these applications, get some specific information, up-to-date information, for insurance, prediction markets, or consuming specialized information for your needs. They can pay for this information because AI agents are here, but monetization, that's not yet pretty much widely available. There are some approaches, and we believe that regular payment gateways, they cannot keep up with all the AI agents are created or running nowadays. And blockchain, obviously, it can with private execution, Flare confidential compute. I think that is a perfect ground to build your AI applications. And with that thought, I will end. If no other questions, then thank you for checking out this webinar, either in live or in recording. And if you have any questions, then send us to any socials or go to our Flare Dev Hub. And yeah, pretty much that's it. And see you in the next webinar. Thank you, everyone.